the first thing I want to do is we want to apply the concept of integration as area. So interpreting the integration as area, and with that interpretation, we want to do problems. Okay, so interpreting the integral or whatever. I mean, it is area, but we want to focus on that interpretation more. Okay, interpreting integral as area. I mean, that's what integral is, but we want to specifically use this interpretation. So the first question in this is the following. Let f be a this function, let's say from 0, 1 to, let's say from 0, 1 to 0, 1. No, let's not say that. Let's say from 0, 1 to a, b. Okay. And f is everything. F is continuous, integrable. Those things will not be that important today, maybe. Continuous in this part, differentiable, and so on, everything. Okay. And the key thing is that f is bijective. Okay. F is a bijective function. Now, given the integral from 0 to 1 of f, okay, find, you can assume this is some c, whatever. Find integral from a to b of f inverse, maybe I should say, though it doesn't matter, f inverse t dt. It's a very simple problem. And it will lead to a useful lemma. Let's think about this. Like from the integral of e to the power x, finding the integral of log x, and so on. So not the indefinite, not the antiderivative. Okay, the antiderivative can be complicated, or we'll see, but just the resulting, the difference from FB and FA. Yes, it's given. So you can assume it is some number, but basically we want to connect these two things. So you can assume it is some number, let's say some I don't know, some x. And f is not given. So what we'll be proving will be a general feature. Think. Hmm. Okay. Mm-hmm. Right. So this diagram is certainly incorrect, right? Because this diagram, there is a minima. So in the middle. So we don't want this wrong. It has to be injected, as you have kind of indicated. So we can no, not like this. Okay. And this is okay. Right. All of this. That is not a bounded. Yes, that is, we have already, yeah, we have used that. So that obviously implies F is monotonous. Certainly, otherwise, obviously, there is no inverse. Yes, certainly. Yes, so that method will certainly work. Right. That will certainly work. But my point is that we can just see it from the picture. Okay. I think Adesh has already kind of said that, right? So if you consider this interval A to be as the input axis, is the input line segment as the inputs, then for this input, this output is, so this is y comma f inverse y, right? So I mean, all this is very simple, but if all this here, so if this is x, right, then you can see this is a very simple problem. Okay. Yeah. And then this is the y. Yes. X plus y is equal to b into 1. So is this, will this always be correct, or do we have to, like, why is a not coming in the picture? No, it can be less than 0. A can be less than 0. So then what do we do when a is less than 0? Let's do that quickly. Right. But can we give a clean formula? Is it possible? Okay. A plus b minus y. So a plus b minus y. This will be x. This is x. But then does it match in our situation? No, right? He means when it is negative. Okay, so probably you can work it out, right? So a simple thing will work. So my point is that though this is a very simple thing, we sometimes forget this. Okay. We sometimes forget this, and this can also be used to come up with any, like you can also draw some inequalities from here. I don't have the problems prepared, but you can understand if you use this interpretation, sometimes this, some extra bit or something, we take the minimum of something, it can be used to, I can vaguely recall, though I don't have the problem in front of me. Okay, but you can just have this kind of this model of the integral of f inverse, as this can be very useful. Okay, so since I don't have a problem, I cannot give it now. I don't remember it. It will take time to make it up, but I will suggest you, I remember one problem which can be done by a similar technique. So so find the derivative of f inverse, okay, in terms of f geometrically. Let's see if you guys can do this. It's a very good practice to interpret these things geometrically, as you have seen even previous problems, the geometry, visualizing it, I shouldn't say geometrically, just visualizing it was the key to actually proving it in the end, right? So try to do this. Yeah. Yes, I think he was, okay, that was a substitution, right? So just, so I think if we have this, yeah, Rasur, I think you should say, that will be better. Or x equal to f of y. Sorry. Oh, sorry. Yeah. Okay. T equals to T equals to f of y. Yeah. So you see, both of you can work this out. Okay. I mean, all of you can work this out. It is simple. Dot dot dot. I'm not completing it. Yeah. And this again, this technique is also very useful, right? You would remember problems where this was the key you would have encountered. I think ISI problem was, yes. No. But that is the what to say? That is not the geometric method. That is the usual method that is used. Right. First you go about proving that such a thing exists, right? That it's differentiable, that f inverse is differentiable. You prove that, and then you use the chain rule. Okay. So, but we are trying to do it geometrically, like the way we did now. Okay, this problem, the integral problem, we did geometrically in the same way we want to do. You should try. Otherwise, it's trivial, right? I mean, all of us can, we may remember the answer. But do this geometrically by this interpretation as slope, and this graph of f inverse as. Yes, yeah, that. But interpret it as the graph that we've interpreted now and try it. That will be a good practice. Try this. We'll discuss this together next time with the last day's problem also. Okay. Yeah. Next I want to do another application of the integral as area. Okay. Let's think about this. This f inverse. Okay. Yes. Okay, then it's good. Okay, so yes, so let everybody try it. Let everybody try and work out the details. It's easy. Right. Okay, here is another question to think about. If integral from 0 to 1 fx, these are some small problems. Okay, if this is positive and integral 0 to 1, let's try this. I don't know an answer to this, but let's try this, is 0. So does it imply, you know what I'm asking, does it imply that yes, I think so, yeah. Yes. Yes, hi Sampath. Yeah, there was a confusion about the timing. This is a fresh problem we are doing. We did one problem, so we are doing this fresh problem. And the theme is to answer questions about integrals by interpreting them as area to get some intuition for things. And let's see. Everything is given. So again, as I've said in the beginning, this is not about the function, like it's not about those things. It's just about geometric properties. Yes. Okay. Right. But so how do you explain? Yeah, I also don't know the answer, but I think this is not true. But we can take a graph which is, for example, on the 0 to 1.0 to 0.5, it's let's say 2. 0.5 to 1. Right. Okay. Right. Let's see. Yeah, that should work. So this time I should do, but then will the still the integral can? Yes, but you can make an example which is continuous. If it's existing like this, you can always do some very small thing and do it. But yes, that's right. So maybe, but let's see this example then. Let's see if this is. But if we reflect about, mhm. So maybe we can also do a line which goes from 2 to -1, which is continuous. Right. But yes, that should. But let's first, let's just check if this one works. Yeah. I mean, this does work, but let me just check it, I think. So right. And so why does this not work? So it is simply because it just becomes negative everywhere. Right? Does everybody see that? Yeah. So this was a very silly question actually. So I didn't know the answer. That just came to my mind sometime back. This, okay. So basically fx times gx is negative everywhere. Okay. Yes. Okay. So maybe this is a homework. Construct a continue homework, and I mean actually not a homework. You can just see basically. Yeah, it's a silly question. Right. Yeah. Yes. Yeah. 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 So I was I was thinking something else, but it's much simpler than that. I had a other kind of intuition, but it's much simpler than that. Okay. So this is fine. Let's get to some more serious stuff then. Okay. Just give me 1 second now.